Good afternoon, my dear students. Welcome to this chemistry digital class. Dear student, as you know that in the last week we have started our organic chemistry, and as I told you that organic chemistry, to study organic chemistry, it is very interesting if you will study it in the way it should be studied. So dear students, in organic chemistry, as we studied that in old concept, the organic chemistry is the branch of chemistry which deal with the study of living organisms. But according to modern concept, the organic chemistry is the study of organic chemistry which deal with the study of hydrocarbons, that is the compounds of carbon and hydrogen. So in the same series, in this chapter we studied introduction. Now today especially I'm going to tell you about the classification of organic compound. From this classification also you will come to know so many things, so please watch this video carefully. Next 20 minutes I'm going to clear so many things that I think you should know while going to proceed in this chapter. So organic compound can be classified on the basis of two things, that is, first is arrangement of carbon atom in molecules, or you can say on the basis of structural, on the basis of structural, how to draw the structure, okay. And the second is on the basis of functional group, so it's okay, here we will talk IUPAC, the nomenclature, but here we will classify organic compound on the basis of structure. So on the basis of structure, basically the organic compound are two type. First is the acyclic, or you can say open chain, and second is cyclic or ring structure, okay. Now if I'll talk about acyclic is open, which can be I can say aliphatic also, which can be known as aliphatic. Cyclic is different. Cyclic is of two type. It is cyclic, which doesn't have a alternate bond, double bond. There can be single bond also, but ring structure, that is called aromatic here, okay. So these are two types. If we will talk about cyclic now, cyclic is two-way. Cyclic is also of two-way. Number one is, if I will tell, homolytic. It is homocyclic or homolytic. Let it be homocyclic only. It is homocyclic, or I can say carbocyclic, because you know the chain of carbon we have to make. Second is heterocyclic. Now what do you mean by homo and hetero? As dear students, you know very well, the meaning homo is same, okay, and the hetero mean not same or it is different. So now if I tell homocyclic is also further divided into two part. It is alicyclic, it is aliphatic cyclic, or aromatic, okay, this ring structure. Aromatic is also two type. It can be Benzenoid or it can be non-Benzenoid, okay. Now try to understand. And heterolytic is also two type. It is alicyclic heterolytic, or it is aromatic. In the same way, here same type of ring will be there, same type of ring, here different ring can be there also. So now one by one let's discuss the examples. If I will take example of first, that is aliphatic, so very simple, all those compound which are aliphatic compound are called alicyclic or acyclic, sorry, and it consists of a straight branch chain compound. For example, if I'll talk about CCC, so with every C there is hydrogen. So you can see the carbon, you just focus on carbon. This carbon chain is very straight chain, or it can be like this way: hydrogen, 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 and hydrogen. So dear student, if you will see here the chain of carbon, it is somewhere like this way. It means the branch is there. Okay. So acyclic or open chain is like this way, where there is some starting point or there is some end. So it will start from here, it is end. It will start from here, it is end, or it is end. Whereas in cyclic, there is no starting and end. The starting and ending point is same. Like cyclic compounds are those compounds which contain one or more closed chain. So it is of two types. We have already studied homocyclic and heterocyclic. Homocyclic are those compounds which contain ring which are made up of only one kind of atom. Which is made up of only one kind of atom. Which is made up of one kind of atom. Whereas heterocyclic is where it is found more than one kind of atom. If we will talk about alicyclic, so some example of alicyclic I am going to take. Alicyclic are all those carbocyclic compounds which resemble aliphatic compound. In most of their properties, the compound are like this. This is, you can say 1, 2, 3, 4. Although it is a closed, but there are 4. Then this can be there. Then this can be there. Then this can be there. Okay, this is you can say square. In mathematical geometry it is square, but here it is cyclo. How many carbon is there? 1, 2, 3, 4. Butane. And here 1, 2, 3. Cyclo word we will use. Propane. Carbon, 5 carbon. Cyclo, what is the carbon compound in which 5 carbon is there? Yes, pentane. And it is cyclo 1, 2, 3, 4, 5, 6 hexane. Now dear student, why it is called homocyclic? Because you can see here in all the 4, 3, all angle there is only carbon atom. So this is made up of one kind of atom. That's why it is called aliphatic cyclic. Okay. If aromatic compound, we will say this compound containing one or more fused or isolated benzene ring. Now difference between alicyclic or aromatic. In aromatic there is double bond at alternate carbon. Suppose this is 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon. Now carefully see here. At number carbon 2 there is double bond. At carbon number 4 there is double bond. At carbon 6 there is double bond. It means that double bond is between C2, C4, C6, alternate carbon. That's why it is called aromatic. And aromatic word came from aroma. Already I told you, sweet smell. Okay. All those compounds which is aromatic that have sweet smell. Now if we'll talk about benzenoid and non-benzenoid. So benzenoid are those compounds where benzene ring is appeared. Benzene ring is what? There is this 6 carbon with at alternate number there is double bond. So this is benzene. If I will draw other compound of benzene, there is CH3 benzene, that is toluene. Now whatever I am drawing, whatever structure I am making, just make it sure, dear student, you must know the name nomenclature. The name of benzene is this. Benzene can be drawn like this, toluene can be drawn like this. Then one more we have, benzene is same, but here when functional group is changed, NO2, the word will become nitro benzene. Similarly, some more examples are there. Same benzene is there, then NH2 is there. Now the word become aniline. Then again OH, phenol. These are some of the examples of benzenoid aromatic ring. These are the example of cyclic, aliphatic cyclic ring. Basically this ring, this if I draw one, this is basically like this, C, 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 C. 1 H is there, 2 H is there, because 1, 2, 3, 4. Each carbon there is 4 bond, so 2 hydrogen, 2 bond with each carbon. So this structure is like this one. There is no double bond. That's why it is called aliphatic. This structure changed from where? This structure changed from here. See here now how many carbon is there? 1, 2, 3, 4, 5, 6 carbon. And with each carbon there is hydrogen. Hydrogen, 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 and hydrogen. It means there is a 6 carbon and 1 2 3 4 5 6 7 8 9 10 11 12 13 14 hydrogen when we are talking about simple hexane. This is aliphatic simple hexane. But when it will make chain mean this carbon will attach with this carbon, then only it will make chain. ओके जैसे आपके पास एक सीधी सी चेन है और आपने एक एंड पकड़ा हुआ है, एक एंड पकड़ा और फिर आपको उसमें जोड़ा हुआ है, दैट एंड इज लाइक अ चेन and at that point 2 hydrogen need to be reduced. 1 2 3 4 5 6 7 8 9 10 11 12. Now in cyclic there is formula C6H12, whereas in simple aliphatic the formula is C6H12 H14. It means that 2 hydrogen is more and 2 hydrogen is less in cyclic because 2 hydrogen will make bond. These 2 hydrogen, one and this hydrogen will combine with each other and it will make a cyclic. Okay, so hope so you got that how cyclic compound will form. Now most important, these all compound are monocyclic, mono benzenoid ring, मतलब single benzene से ring बने हुए. There are some compound which is formed by double benzene also, like 2 benzene or 3 benzene also, like this is one compound. This is one compound. So the name of this is naphthalene, dear student. Naphthalene. You have heard this name so many times, naphthalene. Sometime you know that in public toilets or in your almirah where you kept cloth, you got white color tablet, गोलियां होती है जो सफेद रंग की, फिनाइल हम बोलते हैं इसको. That phenyl is naphthalene actually. Okay, and it is sublime substance. It can be sublime very easily. मतलब solid से directly gas बन जाए. ठीक है. So there are some more compound where more than one benzene is there. Like this. This is anthracene. Anthracene mean 3 ring. Okay, now these are benzenoid. This is monocyclic benzenoid. This is I can say more than one benzene ring. Okay, now non-benzenoid, this is benzenoid and this is non-benzenoid. Now if non-benzenoid, I will say non-benzenoid those compound which do not have benzene. What is benzene actually? Benzene is where 6 angle is there, 1 2 3 4 5 6. Dear student, while you are drawing this benzene, take care it should be in a fixed shape, proper shape. Each bond, each side, each dash should be equal. बड़ा छोटा नहीं बनाना है, ठीक है. Now non-benzoid, if I will draw a structure that is having suppose 1 2 3 4 5 6 1 चलो ठीक है, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7th carbon with 7th carbon there is oxygen. When we have such kind of structure, these structure are called non-benzenoid and this is the example of tropolone. Okay, now we will talk about heterolytic compound. Heterolytic compound is also having 2 types. It is alicyclic and aromatic. These alicyclic aromatic I am going to tell you, these alicyclic and aromatic I am going to tell you with the help of my book. So dear student, you can see here heterocyclic compound, cyclic compound containing one or more heteroatom in their ring, which is called heterocyclic compounds. So in which there are 2 types, alicyclic heterocyclic compound and aromatic heterocyclic compound. In alicyclic heterocyclic compound, the compound containing one or more heteroatom and different atom. See here there is carbon and here one oxygen. It means that different atom हुए कि नहीं हुए. So the name of this is oxyrane. You need to learn all these names. Second, here carbon, 4 carbon, 1 oxygen, tetra. That's why tetra word, 1 2 3 4. Tetrahydrofurane. Carbon, pyrrolidine. These are some of the example of heterocyclic compound, aliphatic compound. Now aromatic compound, the same structure. When double bond is there, the name will become furane. When NH is there, it is without bond NH, then it is pyrrolidine. With bond NH, here is bond pyrrole, pyrrolidine, pyrrole. This is the name change. With S, thiophene, you can say thiophene. With nitrogen, there is a pyridine. Okay, so these are the, dear students, the classification of organic compound on the basis of structure. Now second type of classification on the basis of functional group. That also I want to tell you from with the help of this book. It may be defined as the atom or group atom joined in a specific manner which is responsible for the characteristics which is chemical property of organic compound. Like if OH is attached, then alcohol; if CHO attached, aldehyde; if COOH is attached, carboxylic. This we will study in IUPAC nomenclature. That is our next topic. Homologous series, you know very well, there is same type of number of carbon but different functional group is there. That is also homologous series. So let's discuss homologous. If I'll tell about homologous, all those compound with same functional group belonging to same functional group but different word root. For example, if I'll tell you here 1 2 3 4 carbon, you studied in 10th class, is called but. Single bond is there, AN, but function group is OH, alcohol. That's why name is ol. So it become butanol. 4 carbon, 9 hydrogen, 1 OH, butanol. Same type of compound is there, whereas 1 2 3 only carbon. The 3 carbon compound is called prop, and single bond is there, AN. Functional group O is there, OH, ol. 3 carbon, 1 hydrogen. So these both are homologous series of alcohol family. Similar way, there can be aldehyde family, there can be chlorine family, there can be fluorine family. Got my point? Those all compound are called homologous series. This is all about the classification of organic chemistry. With this, a small topic is there, that is structural representation of organic compound. It means that all the organic compound that can be represented in different way. You can understand that somewhere we are writing this way, we are writing like this, okay, somewhere we are writing like this, and somewhere we are doing like this, somewhere we will do like this, okay, and somewhere we will do like this. So my question is there, why there are so many different type of structure? This is very important. Organic compounds, dear student, these organic compound have some structural formula, and those structure formula can be represented on the following way. First is Lewis structure. There are 5 different ways. Second is complete structure formula. Third is condensed structure formula. Fourth is bond line. Fifth is polygon. A very small difference is there, one by one. Lewis structure formula, you know already. Lewis dot structure. The outermost electron will be shown with the help of dot. There should be 8 electron in outermost shell. That is called electron dot structure. It is the method the bond and electron are arranged around the constituent atom of molecule with the dot, with the help of dot. This is electron dot structure. You did in 10th class. If you don't know, so you please ask me, I will tell you again. Electron dot structure. Second is complete structural formula. Complete structure formula is the formula that is in which bond is represented with single dash, double dash, like this way. We are showing bond in a dash. Okay, for this for example, this is structure 1 2 carbon is there. It means that C2 1 2 3 4 5 6 hydrogen is there. It means that's it. It can return C2H6. It can return C2H6. But if we will tell about the complete structure formula, then it will be written in the open form. When we are writing structure in open form means by खोल के सब कुछ dash लिख के, that is called complete structure formula. Third is condensed structure formula. That is, suppose if C2H6 will be written in condensed, so we will write CH3, CH3, 2 times carbon, 3 plus 3, 6 times hydrogen. That type of structure is called condensed structure. The structure formula obtained by omitting some or all the covalent bond and by indicating the number of indicating group, that is called condensed structure formula. Function group will be written in this. Fourth type is new type of structure formula. Although electron dot structure, complete structure formula, condensed structure formula you have studied in 10th also, but bond line structure formula. In the bond line structure formula, you will each carbon, suppose if I will make this type of formula, so this will be written in this way: 1 carbon, 2 carbon, 3 carbon, 4 carbon, and here is double bond O. So it means that this structure will be written like this way. And you need to understand automatically कि here is hydrogen, here is hydrogen, here is hydrogen. वो खुद समझना पड़ेगा. That are not shown and the represent. The hydrogen atom are not shown in this type of structure formula, and it is representing carbon-carbon bond with the zigzag fashion. The junction denote C atom which is bonded appropriately number of hydrogen. और आपको this year you will get this kind of nomenclature. So see here 1 2 3 4 butane is there. It means that 1 carbon, 2 carbon, 3 carbon, 4 carbon is there. Okay, 4 angle means 4 carbon. So 4 carbon name is butane. Now similar way, see, terminal is what now? Terminal. terminal mean which side we will start. 1 2 3 4 5 6. Now this is here, it means that it is like this way, CH3. So at number 1 2 3, 3 methyl, 1 2 3 4 5 6 hexane. Okay, this is hexane group. And if this will be 1 2 3 4 5 carbon is there, pent at number 1 2 carbon there is in, pent 2 in. Hope so you got. Fifth type of structure formula is polygon formula, in which there are many organic compounds in which carbon atom are not joined into the chain but are joined in the ring, like cyclopentane 1 2 3 4 5, cyclopentane, cyclopropane, cyclobutane, chlorocyclohexane, cyclohexanol. Already I have told you cyclo word why I will write, because it is a cyclic form, ring form. And one more thing, that is three-dimensionally how we can represent the organic molecule. It will be represented like this way. Suppose for example we are writing methane structure. Carbon is in center, 4 hydrogen is there. 4 hydrogen is shown how? In one hydrogen there is a 2 dash. In third hydrogen there you can say dash line, dot line. The dashed line or dash wedge is shown bond away from observer. Away from observer, if we will see three-dimensionally, so that away mean that side. Away mean this side. हमारे से अगली तरफ को, that is called shown by dash. Solid line which is toward myself, 3D it is. Okay, like if I make a bond like this way, so which bond is away from myself, which bond is away from my side, that is shown with dotted. Which bond is toward my side, that will shown in solid line. Which bond is in plane of paper, like ऐसे हमारे दोनों side left and right, that will shown in the simple dot. So there are some of the structure representation that we have studied. So dear students, two topics we have studied today. One is classification of organic compound, basic total theory. Second is structure representation of organic compound. So by keeping this information in mind now, we will do nomenclature tomorrow, or in my live class I will tell you the nomenclature. So with this topic is finished. So hope so you got and you enjoyed the video. Please once again watch this video carefully. Tomorrow we are going to do the nomenclature of organic compound, that is called IUPAC. Okay, so thank you. Till then, take care, stay home, stay safe and stay healthy. Thank you.